Huawei. So today I will talk about the live migration with the SR-IOV pass-through. Okay, so the live migration is a very important feature of virtualization, and it's already widely used, right? And now, because the network is become more and more powerful, like 10 gig to 40 gig and even 100 gigabit. So the SR-IOV pass-through will be migration will be required in most situations like NFV or other network heavy workload scenarios. Here is basically live migration algorithm. So yeah, here is the no news here, but important point is like the data page login and copy the data page iteratively and suspend on the source side and resume restore on the destination side. Okay, so here is just as a basic picture of the live migration. Okay, so for the SR-IOV migration, there are challenges. As you know, if we use the emulated device, the status is can be saved and restored in the hypervisor or QEMU. But for the assigned device, because the hypervisor won't involved too much on that, so the VM can directly access the physical device. So the physical hardware status cannot be checked by the hypervisor, and so it's hard to migrate. And existing NICs, some registers are not writable, so it's also you cannot after the migration you cannot write some status back to the physical device. So in a few years ago, so somebody proposed some solutions for the SR-IOV migration. Bonding driver is one solution. So that means it will binding the assigned VF and virtual NIC device in the VM and using the Linux bonding driver in the VM. So normally it will use the assigned VF to do the networking. But when start to migrate, it will switch to the virtualized device. So, but here we can see there are some issues. One is the performance is not consistent because it will switch the assigned VF to the virtual NIC device, so the performance will be different. And also, the CPU consumption is also not the same because the pass-through it don't need lots of the CPU consumption, but the virtual it will be cost more CPUs, so it will also be a problem for some scenarios. And also the bonding driver it involve the hot plugging the VF and plug and unplug the VF, so it also will increase the downtime. Okay, so in our appearing using the pure software, it's not easy to support the SR-IOV migration. Okay, so we did a prototype. So simply thinking is, why not make the hardware to be friendly to the migration? So here we think make the NIC register can be readable and writable. So so it can on the source side you can read the status, And after the migration, you can write back the status. And also for the network driver, it need to provide the suspend or resume functions that you on the source side you can notify to invoke the suspend to save the hardware state, and after migration it can you resume the status. So it's the very directly thinking about that. So based on that, we did a prototype. So we based Huawei's smart NIC prototype, and we did. Here is the prototype overview. Okay, so it will involve like Liverwood. It's simply need to do some migration check, and also we'll do some modification for the VM config. On the QEMU side, for each assigned VF, it will also have emulate the device in QEMU. So we need to implement the save VM handlers for that. So it can be can save and restore some emulated device status in QEMU. And also the IP root tool, it's already supports the VF management command like enable, disable, and auto. So we also reuse that and add more commands for migration. And the driver side, it need to let the for the PF side, it's just a very simple change. It needed to handle the migration command and notify the VF driver. So on the VF side, it will do the data page login and will implement the suspend and resume VF state. So here is the overview. We can go to more details later. So here for the live migration with the SR-IOV pass-through, so it will need some changes. Here is also the overview. On the config VM config side, it will need to configure like the VF BDF of the destination VF, and also need for the data page login. You need when the live migration starts. We will notify the VF driver to check the DMA data page. On the suspend, so it involves two things. One is need the VF driver to do the save. The other is it will, in the QEMU side, it will also save some status of the emulated device. So on the destination is after the restore, it also will it needed to load the two parts. One is in QEMU status. The other is let the VF to do the resume. So so the process is very directly.
When you say VF driver, you're talking the driver and the guest?
Yeah.
So it's a cooperative model with the guest driver?
Here, for the IP root, so we extended some commands based IP root. So for migration, we added 4 commands: migrate, cancel, migrate, suspend, and resume. So the migrate is it will notify when the migration starts. It will call this command to notify the driver to start data page login, and it also can cancel before the live migration done. And the suspend is will notify the driver to do the suspend, and the resume is do the resume. Okay, so on the PV driver, it for the IP root command, the PV drive, the PF driver will just pass the command and notify the VF driver there. So via the mailbox. Okay. So for the DMA dirty page logging, so memory access by DMA cannot be automatically checked by the page table like EPT. So for the assigned device, so how to check the dirty page by its DMA. So the solution is we use the dummy writes in VF driver. That means when the VF driver receives the packets from the physical NIC, then it will directly do read and write on the same address. Then the memory will become dirty. Then so the memories can be checked. Okay, so and we also notify the observe the performance when start the lab migration. When the dirty page logging is enabled, we find it almost don't impact the performance. Okay, so the VF state migration is so on the suspend side, the VF will do the hardware status save the hardware states, and then it will down the interface. And so the on the QEMU side, so because it will register the save VM handler, so it will be invoked by the migration process.
Can you repeat the explanation of how DMA birth page was checked?
Dirty page, so here is the dirty page is the VF driver will just read the 1 byte and write back. So this is dirty. Okay.
Use the process to make it, happy.
Okay, so for the for the VF resume, it's so it's first will be the QEMU side will restore the status, and then it will notify the VF driver to do the resume, and up the interface, and the driver also will at last will send some ARPs to set up the connections back. Okay, so here is the basic prototype process. So, and we also did some evaluation based on this prototype. The environment is simple. We use the Huawei's prototype NIC, and for the migration NIC is 1 gigabit, and use the shared storage. And the VM is 4 gigabyte memory. Okay. So here is some results about the total migration time and the VM downtime. So here we can see the impact on the total migration time and the downtime is little. So here is the VF, we compared the VF with the Water unit, and the VF with the assigned VM with the assigned VF. So here is the idle 1 gig and 5 gig. It means the VM's network load. What? Yes, okay. So here is we also compare so here the downtime is the number is from the QEMU. QEMU has the variable where to show the downtime. So we also use it to evaluate the network service downtime. We're using the ping command to the ping will be periodically ping the VM network, so we can calculate the downtime, the network downtime to calculate the loss package of the ping command. So here we find, except the 5G, others looks no big difference. So our prototype we have some additional time of downtime is the suspend and the resume. So we also evaluated the VF suspended time. It's about 5 milliseconds. But we found that the resume time is about 20 milliseconds. It's bigger than the suspended time. It's mainly costed in the app interface. So here we think it can be optimized. But we need more tuning on this. Also, for this case looks very strange. So, but currently we don't know why. So it's also need more tuning.
Have you tested the TCP collection? That is the real ping time. Because the ping time is similar, a little bit bigger than downtime, but the TCP time, there's no return window. If you miss this window, the TCP ping time will become very big. Have you tested this?
No, we no test. We just simply use a ping to test that. Okay, so here is summarized. So we, because the SR-IOV migration is not easy to do that. So here we are thinking is using the pure software is not it's very challenging. So and we tried with some hardware support on that, and we demonstrate the prototype, and it basically works well, we think, but it still need more tuning or improvements on that. So for this we are just it's to try that and to see how the hardware and the software needed to do for that SR-IOV migration can be relatively easily implemented. So at the last year, we hope in future the more NICs can be more friendly to the live migration. Yeah, so this is my presentation. Okay.
Since the downtime of the NIC is visible to the guest, do you still need to do a bonding mode with a VirtIO to prevent losing connections?
We don't use the bonding.
It's without bonding.
Right, it's without bonding, but then the NIC downtime is actually visible to the guest, so your connections are going to be lost. So, yeah, that's why I'm asking whether you need to do it in a bonding configuration to maintain the link connection, even to that 1.6 seconds of downtime.
Honestly, it's really just a bug that you see 1.6 seconds downtime. It shouldn't be that bad. It's probably just a link negotiation that I had to get up the port or something because the port wasn't up. There's probably something else going on that sounds fishy. There's no reason why this mechanism should not get you similar performance to normal VirtIO transmission.
Isn't the guest going to do a DHCP when it comes back on the other side?
The guest should not be able to see that it's going down, really. It's what... Oh, you're actually taking the network interface down?
Yeah.
The guest to involve.
You don't... Okay, wait a second. You can probably, if your hardware supports proper like migration of all of the registers and your heads and your tails and everything, you can probably get away without taking anything down at all. You just when the guest CPUs are stopped, you just basically send a command to the NIC telling it to stop processing the queues, and you just fetch the state, push it back in, and you're all good. There's no. Yes, but you don't have to.
Yeah, so
If your hardware supports migration of all the state that it is available, you saw my presentation, right? The big hassle I had was that not every piece of information was visible. In his hardware, apparently, it is visible to the user of the VF, which means he could just use my approach, throw away all of the other stuff that I have there, all the nasty tricks, just directly fetch it from QEMU, say, I want to get my packets now, I want to get my state of the device now, push it back in on the other side, and they don't get any downtimes, really.
You told that the problem with the hot plug doing the bonding and the hot plug was doing the hot plug when you finish the migration, that it was too slow. And really telling the guest and the car that launching IP Road 2 and telling resume is going to be faster than just doing the hot plug.
So you mean compare the time cost between the unplug and the resume?
Yes.
Actually, we didn't compare the times. So, but the unplug hot plug is somehow it's a heavy operation for a VM. So. But we didn't exactly evaluate the times of the.
But if you are doing bonding, the guest didn't show it, because when you finish, you still have one virtual net, whatever. You do the hot plug, and when the hot plug finishes, is when you remove the old one. So it doesn't matter. It doesn't matter so much. And the other problem is that you are saying that you have the guest driver collaborates with migration.
Here is So here, the prototype. We need to modify the drivers and something by with the hardware team. But in future, if the NICs they can friendly to the migration, so I think the NIC vendors they will provide the drivers. So just they need to provide the suspend and resume functions.
But the problem is that as QEMU works for migration is that you stop the vCPUs, you send all the memory, and then you go to the drivers, to the devices. That devices, if you tell the VF, the network device at that point that stop, you don't know, if all DMA operations have finished, you don't know. The guest cannot write to memory and telling this operation, this memory is still being used, because it don't know. The guest is stopped. Only the host is still running. So we don't know if the DMA have finished at that point. And at that point, the guest cannot help because the guest is stopped. And in destination, we have the same. When we receive the state, we tell the hardware, please, you can be configured again. But the guest is not running. So in a package arrive, we don't know what is going to happen because some DMA hardware is going to happen, whatever, and the guest is not running yet. And the driver in the guest cannot help here because it's not running yet. So basically, we need to modify the driver in the host, the driver in the guest, and put the QEMU in the middle. So I can see how the guest is going to help here. Sorry.
I have exactly to that point a question, because I don't get why you need DMA tracking at all. Because in the guest, if you anyway do the cooperative mode here, you know what's going on. You know which slots you set up on your NIC to receive a packet. Why not implementing a stop function to shut down the NIC, right? So saying, this queue is stopped, this queue is stopped, this queue is stopped, and then all the DMA operations are disabled then in the end. Then you notify your host, you're done, the device is down, please migrate me now, and then on the destination you...
We are telling that the We are telling that the problem is that stopping the guest, stopping the NIC to do a hot unplug is too slow. And what you are telling me is stopping the NIC. I mean, calling it any other name. But it's the equivalent of doing one unplug. And what is the difference between unplug the NIC and telling the NIC, stop, wait for all DMA, and now give me all your state and restoring the destination? I mean, it's the same.
I don't think that's the real problem. It's the fact that virtio is too slow, failing over when you're flipping over virtio net. That part is too slow. Not the unplug. The fact that virtio net simply can't have the performance.
So the hot plug is one problem. So for the binding driver solution is several other problems, issues here.
But the bonding is going to be used only since you stop the guest and you started the destination. And that is where all our problems are being, to have the SR-IOV working.
So you mean just use the hot plug to do that?
Yes, I mean, okay, instead of using the hot plug from the beginning, use it later. Okay, the bonding, I mean, you can set the bonding later in the migration string if you feel like that. But what you are doing basically...
Sorry, I can't take this anymore. You cannot use a bonding interface if you want to do any NFV workloads, because your NFV workload is most likely going to run on DPDK in the guest, which is going to use one interface and one only. You cannot have a bonding interface between those two. Any solution that is bonding, and honestly any solution that makes the guest aware that it gets migrated, is fundamentally broken. You do not want that, period, ever. No, they have a solution that gets you closer towards the goal that you want to have. The whole idea of making the guest aware and talking to the guest while it's getting migrated to save some state is pretty stupid. I don't think that's good. However, the idea to have the guest help you on dirty tracking of DMA is not too bad. Actually, I find that pretty nifty. Yes, you do lose the last couple DMAs, but you also don't know that the guest is not running, so the guest is definitely not going to write new descriptors into its receive queues. So if you have a hybrid solution there where the host is already aware what the guest is doing, you can actually just, at the point in time when you stop the guest CPUs, you can take all of the guest queues all of the DMAs that the guest could potentially have written, or that the device could have potentially written to, because you do know that when you exceed the ring, there's not going to be any more coming in since the guest is not running, and you can just mark all of those dirty at the end and show all of them over. It's all doable. It's all possible with the approach they have. The only thing that you really need from this approach is the cooperation with the guest to work around the fact that we just don't have IOMUs that give you dirty page tracking. Again, it's a definitely interesting approach, and I like it. The fact that you're asking the guest to stop the NIC, don't do that ever. Always do it on the host. Yes, I agree. We both agree. We both agree.
I have a small question. Why are you using the VF and not the PF? Why not use the physical function to stop the VF somehow? Why using the guest to stop its own NIC when it's being migrated?
Because they don't want to give us the state. The VF can do tricks about you don't know what the state is.
Yeah.
If you do that in QEMU, you have to say, okay, my state is this.
But actually, I know that you.
On the PF, when you use the VF inside the guest, there are certain things that the VF doesn't or shouldn't do, like, I don't know, stop itself, because it's like a security vulnerability or.
So you mean use the PF to stop the VF?
Yes.
I'm not sure.
And to fetch the state. So the PF has access to all the VF registers as well, which means from the host point of view, you can ask the PF to give you this, to stop the VF, give you all the state, and you don't have to talk to the guest at all. That was his idea, basically.
Yeah,
Exactly. I was implementing that 3 years ago.
Yeah, but I don't know the PF can it will use the mailbox to communicate between the PF and the VF, but I don't know the PF can save the different VF status, or I'm not sure about it. Yeah.
For which NIC?
Don't plug. Ever plug. Do not plug. Don't plug. Don't plug. Ever. Do not plug.
Save or restore?
Save restore is good. Don't plug. Why? Because plugging is an sorry, I don't want to have a private conversation. You do not ever want to hot plug while you're live migrating, because hot plugging is an operation that you never can guarantee succeeds. It's something you just tell the guest, can I unplug this card now? And the guest can take 5 minutes to say yes. You don't ever want to plug anything.
That's another problem. How can you fail over the hardware? That in our environment, we just simply use unplug and hot plug. Yeah, and I think that the weakness of save and restore is that you have to use the same hardware, use the same NIC at both sides. But in cloud environment, you have different type of servers. So you bind to the hardware is not a good way, I think.
So if you want a solution to that one, take a look at a presentation I did at Linux Plumbers about 3 years ago, where I basically explained an idea where you would do what he's describing. Just you don't save the state just into QEMU. You pull the state from the physical device into a virtually emulated device in QEMU. You're then running on the emulated device. And then you just basically on the receiver side, you either have native hardware that you can run on, or you're running emulated if you're not fast. That said, I don't think for a cloud environment, that's not exactly where you want to go. This is for data centers, for very specific NFV workloads where you do know you own the hardware, or for just the normal enterprise. For the cloud, you probably don't want to expose any hardware into your guest at all. You don't want to have the guest be aware what type of hardware it's running on. It's just a different use case.
Okay, thank you.